Hello genius minds, this is Newton Backyard and welcome back to my another video after a really long time. So today we are gonna talking about two different type of forces and we are also deriving two different things from them. So one derivation is basically about a proof and the second derivation is to derive the velocity of an object on a orbiting around a larger object. So let's start. The two forces which we are talking about are gravitational force and centripetal force. So let's talk about at first what is a gravitational force. So gravitational force is basically the force of attraction between two bodies having different masses or the same masses, that doesn't depend. So having masses and there is a certain distance between them. So we can write it as, let the mass of larger body is supposed to be capital M and mass of smaller body is small m, and the distance between them can be written as small d, or we can also write it as small r, but I am taking small d in this video. So we can write that the force of gravity, which you can denote it as simply F, or F subscript G, is equal to m mass of the larger body multiplied by mass of the smaller body by d square. But this is a equation sign, it's a is equal to sign, so for this we have to add a constant, and that is capital G. So we got here that capital G is the universal gravitational constant. So the definition is basically the force of gravitation is directly proportional to the product of the masses of the two bodies and inversely proportional to the square of the distance between them. So as a proportionate we can write it as Fg is equal to, not sorry equal to, it's proportionate, is proportional to mm by d square. Okay. So when we add the constant gravitational constant g, it become an equation and we call it as force of gravitation is equal to g capital M multiplied by small m by d square, where g is the universal gravitational constant. Mass of the larger body is denoted as capital M. Small m is equal to mass of the smaller body, or mass having the body having smaller mass or lesser mass, and the distance between them is can be denoted as d or r. So you're gonna say why force is inversely proportional to d square or r square. So that is we call as inverse square rule, and we are gonna talk it about that in our next another video. If you all are physics enthusiasts, we came to a term or we came to a statement that the acceleration due to gravity does not depend upon the mass of the smaller body. So does that why that is the thing? So today we're gonna prove it that why it happens, why the acceleration due to gravity does not depend upon the mass of the smaller body and is always depending upon the mass of the larger body, or why the acceleration due to gravity is towards the larger body, not toward the smaller body. So let's write it down. So at first we're going to talk about another force, and that is the weight force, or simply weight. So weight of a body is equal to mass of the body multiplied by acceleration due to gravity. We can write it as W is equal to m multiplied by g, where m is the mass of the body, g is the acceleration due to gravity, small g, and w is denoting weight. We can also write as Fw is equal to mg. And so we're going to taking it as equation 1 or equation I. Nextly, we also know that the force the force of gravity. The force of gravity is equal to G capital M small m by r square, where G is the universal gravitational constant, capital M is the mass of the larger body, smaller m is the mass of the smaller body by r square, or the mass of the second body, mass of the first body. So here, if you're taking it as equation 2, from equation I and second I will get that mg is equal to g mm by r square. So here, if we're taking it as smaller m, both of the object are the same thing. Okay, so in both the equations we are getting that in both the sides the mass of the other body is getting cancelled out. So g is equal to gm by r square. So the acceleration due to gravity always depend upon the larger body and not depend upon the smaller body. So from here we got the proof. So where, let me write it down, g is equal to acceleration due to gravity this is small g, capital G is equal to universal gravitational constant, and capital M is the mass of the larger body or the first body, mass of the larger body, and R is the distance between the two bodies. The two bodies. So you're gonna question that why we're taking that both of the forces are the same thing. So let me explain you. If there is a body, suppose this is the larger body, this is the smaller body. So if we're taking from the surface, it's pulling this way. So it's also applying some force on this, and the pulling is equal to the acceleration due to gravity g, and this body's mass m. So the weight of the body is equal to m multiplied by g. We're gonna write mg. And also a gravitational force is acting on the smaller body, so we can also write it as g m by r square. So both are equal, and capital M is the mass of the larger body. Here we come to our second derivation. So in this derivation, we are using centripetal force as well as gravitational force. So let me explain how we can relate centripetal force to gravitational force. So as we know that, suppose this is a larger body, our sun, and this is our earth. Our earth is orbiting our sun in a nearly circular path. It's an elliptical path, but we are taking it as a circular path. So it is at a certain distance from the sun, and also it is revolving at a certain velocity. The force on this body or our earth is going towards the center. Okay, the force is acting towards the center, and that we call as the centripetal force. That we call as the centripetal force. And there is also another force that we know as gravitational force, which is attracting the earth toward the sun or towards itself. So here we go as gravitational force. So according to two definitions, both are the same force acting on it. So how you can know the velocity of an object orbiting around another object? Okay, so for this we are taking the centripetal force formula with equation to gravitational force. So centripetal force Fc is equal to m v square by r. So v square by r is the formula for centripetal acceleration, and multiplying the mass we get that m v square by r. So here m is the mass of this body, the smaller body, or in this diagram particularly our earth. And gravitational force is equal to G capital M small m by r square. So here capital M is the mass of the larger body, or in this diagram the sun, and small m is the mass of the earth. And there's a distance between them, we're talking at r. So here we are writing it as r square according to the formula of gravitation. So now taking both them as equation I and second I. From equation I and second I we got that mv square by r is equal to g capital M multiplied by small m by r square. So in both the sides, the mass of the earth got cancelled out, the mass of the smaller body. And here 1 hour got cancelled out with the 2 hours on the other side. So we left with only 1 hour, implies v square is equal to gm by r. So finding the velocity of the orbiting body, we're gonna square root both the side, and we got v is equal to root over of gm by r. And this is the formula for velocity of a body orbiting another body or the larger body. And in this case, Earth is orbiting around the sun. So this is it for the video. Thanks for watching this video. Hope you like the video. Do comment on this video and also like the video. Thank you.